Good morning. Welcome to Advanced Air Mobility. I'd like to introduce our moderator, Dr. Eric Muir. He's the founder and CTO of Volair Technologies, where he leads technology development of pioneering safety, pilot assist, and autonomy systems for aviation. He holds a BS, an MS, and a PhD in aerospace engineering. So you are rocket science. So, from the University of Michigan, go blue. He began his career at Boeing, where he led a team of about 50 Boeing software and hardware engineers in pioneering autonomous flight technologies. These efforts span ConOps definition, test aircraft integration and flight test, flight simulation, and perception localization algorithm development, with particular focus on autonomous taxi capabilities and autonomous landing capabilities. So I'd like to welcome Dr. Muir.
Thank you. Yeah, thanks everyone. Really excited to be here. As mentioned, I'm a Michigan native. I went to school just on the other side of 23 there at University of Michigan. Really excited to be here to host a panel with my distinguished colleagues in the advanced aerial mobility space. And also excited that the conference is happening here in Michigan. I grew up with Detroit, Southeast Michigan being the motor city and being synonymous with the automobile. And as over even just the last decade, kind of this rebranding as the mobility city and capital, it's so nice to kind of be talking about this third dimension of mobility that all of us have worked in for a lot of years. So thanks all of you as well for joining in the discussion. I know that this conference has a lot of ground transportation focus, and the advanced air mobility may be a concept that's maybe notional or unfamiliar to some, and so I thought just start with kind of a brief definition. I kind of tried to blend the FAA, NASA definitions of advanced air mobility. I am sure that the panelists will fill out the kind of the definition as we talk. But broadly speaking, it refers to a new and rapidly emerging sector within aviation that's looking to integrate highly automated and new aircraft concepts into the national air transportation system and enabling further efficient movement of people and goods in both urban, regional, as well as previously underserved areas. And so some of the terms that you hear kind of aligned to advanced air mobility are things like urban air mobility, air taxis, regional air mobility, and their applications to both movement of people, but also large cargo delivery and for public use cases. And so kind of with that, I'd like to kind of start today's discussion with the panelists introducing themselves, their organizations they represent, and just a few words about where they kind of how they piece into this broader AAM ecosystem. So Sarasina, I'd love to start with you. And Sarasina provided some slides. Let's see. I guess we're at the end, so let me step forward here. There we go. Technical difficulties are out of the way now.
All right, thanks. Thank you, Eric, and thank you for moderating. First, I want to thank everybody, also CCAT, for inviting us for the first year for the Advanced Air Mobility panel, because this has traditionally been a surface, a connected vehicle surface symposium. Just a little bit about myself. I also went to a school that was part of this university transportation center, the CCAT. I went to Purdue University. I'm dating myself. This was 35 years ago, and I graduated in electrical engineering. Right now, I'm actually a senior scientist with the Department of Transportation in a congressionally established office with the Office of the Secretary of Transportation. It's called Highly Automated Systems Safety Center of Excellence. And we are a group of national experts that look at reviewing and assessing highly automated systems across all the modes of the department. My other hat is, how many of you know that the Advanced Air Mobility Coordination Leadership Act law, or that it was passed in October 2022? Just with a raise of hands. How many of you even know what the top 2 advanced air mobility companies are in the world and the country? Okay, which ones? Boeing, interesting. Okay. That is one of them, but they are not the top 2 companies. So, and I'll go with that. So this is an audience that probably doesn't know that about advanced air mobility or air taxis. So the other piece that I'm working on is the report to Congress of the Advanced Air Mobility Coordination Leadership Act. However, what this act asked for was that the DOT lead an interagency working group. Do you want to? Which is 19 other federal agencies on how to scale this industry. There were 5 501c6s, including the General Aviation Manufacturers Association, the Aerospace Industries Association, the National Business Airports Association, that pushed this act through Congress because they did not want to see the same thing happen to advanced air mobility as with the drone industry. And what it is that we're great in innovation, but as far as research and development and all the DoD money that's been poured in innovation, but we are not great at scaling innovation and the manufacturing and the operations. And I want to emphasize this is mainly about scaling operations and growing transportation options across the country, including regional air mobility, urban air mobility, and rural access. I always want to say this is a very proud moment for me. Actually, to answer your question, Joby Aviation is currently the top funded advanced air mobility company. This was last June, and at the time, the former Undersecretary Carlos Monier was leading the group. And again, they didn't think that this was, this may be more hype than reality. Where I live in Monterey County, where my husband is from, this was reality. We are actually building these planes and testing them in 3 airports near my home. Whisk, as you mentioned, that's owned now by Boeing, is testing at an airport. So I brought this whole entire group, 70 people, across all these federal agencies to see the maturity of this industry and how we can ensure American innovation and scaling this industry. What's the next slide?
Yeah,
Okay.
I'm actually going to
Okay.
come back to that one. No, but
All
I
right.
wanted to let the others kind of introduce. Yeah, thanks, Sarasina. Next, we have Tom Sherony. I just had to comment. I love the flight suit. I love that it's Michigan colors. I kind of am jealous, actually. I wish I could be here wearing a flight suit. But yeah, Tom, please introduce yourself.
Thank you, Eric, and thank you to CCAT for the invitation and opportunity to speak. So I'm Tom Sherony. I'm the aviation manager with the University of Michigan Medicine Survival Flight Program. For those that don't know, Michigan Medicine owns a fleet of 3 air ambulance helicopters and 1 air ambulance configured Learjet. There's a separation between aviation and clinician in survival flight in that a certificate holder called Metro Aviation is responsible for the aviation side of the operation, and so I'm a Metro Aviation employee, and that allows Metro to be the expert in aviation operations and allows Michigan Medicine to concentrate on their expertise, which is the clinical side. I like to think of myself as a mechanical engineer turned professional helicopter pilot. I graduated from Michigan Tech back in the late 90s. I worked as an automotive engineer for a number of years. And a little ways into that career, I discovered you could go to a local airport and take a lesson in a small helicopter. And this lit a new passion with me, and one thing led to another. I left engineering not too many years after that discovery. I ran my own flight school for a number of years. I've taught several pilots, probably dozens of private pilots, a few commercial, and 1 flight instructor. Then flew for a local TV station for a couple of years in a little bit bigger aircraft. Then for a small hospital in Ohio for a couple of years, and then finally landed at U of M in 2009 as a line pilot flying the Bell 430. And then in 2012, I took on the additional role of instructor pilot and check airman when the university bought a new fleet of helicopters, the Airbus EC-155, And then in 14, they offered me the opportunity to become the manager of the program. So I still hold qualification as a pilot, instructor pilot, and check airman, which means I evaluate many of our pilots as representative of the FAA. And I have about 20 years of civilian aviation experience now.
Awesome. Yeah, thanks. It's great to have Tom here as we talk about these new modes of transportation through the air. And, Tom's someone who represents a mode of transportation a lot of us probably aren't familiar with, but is operating on a day-to-day and it has a lot of, synergies and similarities to the air taxis that we'll talk a bit more about. So, next we have Yolanka Wulff, and appreciate you coming all the way from Seattle. Yolanka and I found out we were both on a flight coming in from Minneapolis that was very delayed, so I'm glad she made it along for the panel.
And you as well.
Yeah.
Yes, it was 2 this morning when I got here. Yes, I'm Yolanka Wulff. I'm the executive director of CAMI, the Community Air Mobility Initiative. Little background on me: I am not an engineer, and I don't play one on TV. By profession and education, I'm an attorney and consultant, and I've spent most of my career working with nonprofits and small businesses. And about 15 years ago, it was through that I became introduced to electric aviation, the electrification of aviation propulsion. But with my background in law and consulting, I spent a lot of time on land use and on sustainable transportation. So as I became involved in this field, I came to it from the perspective of transportation systems rather than strictly aviation. 5 years ago, I co-founded CAMI. We are our Community Air Mobility Initiative. We are a 501c3 public nonprofit, and we support the sustainable and responsible integration of advanced air mobility into daily transportation systems. My other slide will show you some of the resources we've developed, but if you can go back, I just wanted to point out there's QR code and links to our website if you want to access those. So yes, go ahead. So primarily what we do is work with at the state and local level with departments of transportation, though I love from the last panel, I want to call those departments of mobility now. Departments of transportation, planners, departments of commerce, elected officials, to educate about what is advanced air mobility and to really explore how this new mode might be used in a multimodal mobility system. Our signature program has been the Urban Air Policy Collaborative. This is about a 20-hour online course that we run for public agencies and airports that covers all aspects of advanced air mobility and planning and integrating into transportation systems. We're about to start our 7th cohort. You can see up there the different agencies and airports that have participated so far. And then we have recently released 3 more in-depth publications. The top left one there, Planning for Advanced Air Mobility, is a 100-page planning guide that we wrote and was published by the American Planning Association. The upper right is an emerging practices playbook that we wrote, published by NASA. The bottom left is a primer and toolkit for cities and airports on how to do outreach and integration of advanced air mobility. And then we frequently run our AAM 101 short course, which is a half-day course on advanced air mobility, kind of a mini collaborative course. I don't know if you're sharing the slides. All of those have links, but the QR code or the URL will also get you to our website with links to all of those. So I'm looking forward to the conversation.
Awesome. Thank you, Yolanka. Clint.
Let me start my timer here so I don't go over my time here. I'm going to stand up for my quick one. So it's a pleasure to be here. My name's Clint Harper, and I am a recovering aviation bro. I am now a community advocate within the advanced air mobility space and the aviation space at large. And before I get kind of going on that transition, I also want to recognize, that the conference that was taking place, the land that we're speaking on, was once belonged to indigenous people that were stewards of this land, cared for this land, and had a deep relationship, for the nature and life around us. And so it's with that inspiration that I try and also keep in mind as I do my work within aviation, one of the more contentious modes of transportation on this. It's a difficult process, but I'm committed to trying to adhere to those same principles. So a little bit about me. I have 25 years in aviation. It started out in the United States Air Force. I progressed through a number of different career fields and jobs, from aircraft flight line technician to aerospace management, but I spent most of my time in airfield management, where I planned, designed, and operated airports, heliports, and UAV infrastructure. Loved aviation, loved everything about it, loved infrastructure, and wanted nothing else to do, in my life but to be in aviation, around airplanes, around airfields, and those kind of things, until I retired from the military and got onto the civilian side and realized that many of the communities that surround our airports today have to deal with the negative externalities associated with aviation and don't have access to the benefits, that those airports bring to the communities. And so I didn't want to be a part of that. I went to planning school, wanted to pursue a more traditional planning career, but was thankfully encouraged by a professor to re-engage within aviation and try and bring some solutions to the problems that I had within aviation itself. And so that's what I've been doing since 2014. I've worked with the Utah Department of Transportation as a state airport system planner and economic development lead, which is where I was when the advanced air mobility industry really started taking off, and I integrated into my work. I transitioned from there to support the City of Los Angeles as the City of Los Angeles' Advanced Air Mobility Fellow, where I helped lead with the Department of City Planning and the Department of Transportation the integration strategy of advanced air mobility into their mobility strategies and land use strategies. Had a short stint with NASA, doing similar work on the community engagement side. And today I'm a consultant trying to help out where I can, basically a whack-a-mole approach with all this. But my passion is communities. And I want one thing I think that the advanced air mobility industry is bringing, to the table is new diversity. And if you look at just the spectrum of this panel today, when I would go to conferences in traditional aviation pre-2017, it was all one demographic, and I was usually the odd person out, in that demographic. And so the diversity, the advanced air mobility is bringing into aviation is something that I think, an initial win that we can applaud and move forward with. And so it's something that we want to continue building on that momentum, with diversity, with accessibility, with reducing some of the negative externalities, so on and so forth. And so it's with that I'm trying to lead my work, and happy to answer any questions.
Yeah, thank you, Clint. And Dimitra.
Okay, so good morning from me too. I am Dimitra Panagou. I am an associate professor with the University of Michigan. I am now with the newly established Department of Robotics as of 2022, that it formally started being a standalone department. But I have joined Michigan since 2014, and I started in aerospace engineering, where I also kept 0% appointment, so I am both with robotics and aerospace engineering. And these two departments really represent two of my passions, being a researcher in robotics and being a researcher particularly in aerospace robotics. So maybe a little bit more about my educational academic background. I am from Greece. I grew up there and I finished my education there from the National Technical University of Athens. My degrees are in mechanical engineering. But I have always been interested in automation, in robotics, and this type of technologies. So then I came to the US for my postdoc. I was at UIUC, University of Illinois Urbana-Champaign, for 2 years, where I started extending more into aerospace controls and aerospace systems. I was a postdoc at the aerospace department there. And then, I applied for faculty jobs, and I got hired by Michigan Aerospace. So as a researcher and a professor, I do a lot of things apart from teaching. When it comes to research, my research interests span a broad spectrum of planning, autonomy, decision-making, and control for multi-vehicle systems. ranging all the way from marine robotics to ground vehicles to aerial vehicles to space vehicles. As you might have guessed, particularly aerospace robotics has been one of my interests because of working within an aerospace department. And as part of my research portfolio, one of the centers that I am participating along with other colleagues from Michigan Aerospace and Michigan Robotics is a so-called NSF industry or industry university, NSF-sponsored industry university cooperative research center, which is called CAMS, the Center for Advanced Air Mobility and Sensing, which was established in 2022. It succeeded the earlier Center for Unmanned Aircraft Systems, and it comprises 6 universities. One of them is University of Michigan, and about 20 industry, government, industrial and government IIB members. So if you're industry or government participant on this panel and would like to consider joining the CAMP Center, please talk to me. I'm happy to talk more about the research activities in the center because we are really trying to develop collaborative, like the universities, the faculty, the researchers, the faculty and the students, along with the government and the industry participants are trying to solve and tackle all of these research and technological challenges that will enable advanced air mobility and sensing. I guess that can be part of the discussion. I think in terms of introduction, I can probably stop here and look forward to further information, to give you further information about that research direction.
Yeah, thanks, Dimitra. Yeah, certainly a lot of experience on the panel, so let's dig in, leverage that, talk about this. I think, especially, we talked a lot about things like drones, and there's been air taxis, regional air mobility. I think it'd be really great to start the conversation and have some specifics and kind of ground the conversation in some use cases that are, from a business model, being really pushed by this initiative, or from a technology standpoint that are enabling these sorts of things. Maybe just to kick us off, Clint, I know you worked early on with the city of Los Angeles, which is a target deployment city within the U.S. on a lot of AAM initiatives. Maybe you can, kind of give us an example of a use case that, or two that, is really, in the technology that's enabling it, that's being looked at there.
Yeah, so the city of Los Angeles is targeted by the industry as an initial launch city for the air taxi market because of the congestion issues that Los Angeles has to deal with that. And what makes it challenging, and so something that I think we should level set on early on is that this concept of urban air mobility, regional air mobility, none of that is new. Back in the 1950s, helicopter airlines had established in Chicago, New York, San Francisco, and Los Angeles, and were providing urban air mobility within those cities up and through until the early 70s. And then there have been numerous efforts following that have tried to reestablish a network of urban air mobility within those same cities, until now. And so when we look at urban air mobility and what eVTOLs are going to provide, we always want to look at where are we evolving from, because if we look at this as a completely new technology, I think we tend to ignore a lot of the lessons that we have learned in the past with all this, and how the current infrastructure and systems, supporting systems, have been developed in kind with all that. And so the air taxi market, it's very contentious within the city of Los Angeles because right now, air taxis do exist. They exist in the form of helicopter charters that transport primarily wealthy people, across the city, which rubs a lot of other people the wrong way. Particularly if they have to deal with the noise and negative externalities associated with it. Why do they have to deal with all that while the wealthy people get to bypass congestion and all that kind of stuff? And that's something that early on with the industry was a problem. When we talk about, hey, we're going to bring urban air mobility to all the cities and solve congestion, but a lot of times, even in the same graphics that they would share in their presentations, they would show an aircraft flying over a congested highway. So who are we bypassing congestion for? Who is this service for? And I believe it can be for a lot more people. It can be more accessible. But we got to be honest in how we communicate that, and we got to be honest about what's going to take it for this industry to scale in order for it to be more accessible to everybody, and then really look at the use cases that's going to bring benefit to other people in terms of expanded use cases such as medical delivery, because congestion also impacts ambulances, it impacts medical service, it impacts emergency response, disaster response, and all those kind of things. And aviation has traditionally been a solution for all of those. And so how can eVTOLs and other aviation solutions or emerging aviation solutions fit into that realm?
Yeah, and I think, Sarasina, actually, you had a good slide on kind of this, this transportation system of the future, and both you and Yolanka have talked to me about it is a bit of a technology push market, but that there are new technologies that are enabling a broader ecosystem of mobility. So I thought, it's your slide, maybe you could kind of start us there. And Yolanka, I'd love for you to fill in the concepts around sustainability and equity in terms of mobility and how, how these new modes of transportation can really augment existing capabilities and systems.
Right, so I want to talk about this slide, which is creating the transportation system of the future. With the advent, actually we see it across the board, electrification, automation, new propulsion technologies. And I always go back also from history, right? I work for the Department of Transportation. But we have never had a chance to redesign the overall transportation system since the Eisenhower era. Eisenhower, that's where we got the federal highways, the general aviation airports, the airports, that what I saw during the pandemic when they were testing this aircraft, it's like this is a birth. AAM, yes, it's a niche market, helicopter operations, but it was this inflection point, which the Act is also showing, which is a catalyst for us to now, today, with these technologies available, to redesign the transportation system to make it more equitable, accessible, and sustainable. And so I work for the Highly Automated Systems Safety Center of Excellence, and before, I think it was a month before the Act was signed, we were like, yes, AAM's there and drone is there, but how do we make a total transportation and redesign it the way we would want our future generations to do? We've got rural access. Roads are very expensive, right? Advanced air mobility. Our stakeholders have been the state, local, tribal, territorial governments. The Choctaw Nation of Oklahoma is really leaning into advanced air mobility and drones. They see themselves as food deserts so that they can access, advanced air mobility could help them access medical supplies, medical services that many in the rural communities don't have access to. And rural roads are very dangerous. Most of the accidents happen on rural roads. So this isn't just about urban air mobility or regional air mobility and transportation. This is really about how we can look at the transportation system as safer and more equitable.
Yeah, thank you. And yeah, Yolanka, I'd love to have you follow up on that. And I think one thing, so Yolanka's from Seattle, and I spent some time there, geographically challenged area in terms of traffic transportation on the ground. So maybe, we've talked a lot about air taxis. It would be great as kind of part of your perspectives. Walk us through what you think the future of the aerial mobility might be in Seattle, say, in a decade or two with these new modalities.
Yeah, thanks, Eric. I want to underscore what Sarasina has just said and kind of follow on from that. Remembering that, as Eric mentioned, one of the things that we've really done at CAMI is looked at this as a tech push market. And just like the mobile phone 2 decades ago, these technologies have come together to create this opportunity. It wasn't necessarily in response to a particular market demand, just like there wasn't a huge clamoring for smartphones. But now that we all have them, we don't know how we would live without them. And frankly, about the last thing we do with them is make a phone call. So this is a huge opportunity to look at this technology and say, as Sarasina just mentioned, how could we rethink our whole transportation system? How do we rethink mobility if we could add the third dimension? So in an area like Seattle, I actually live on an island, Bainbridge Island, just west of Seattle. And if I could fly into SeaTac, it would be a 10, 15-minute flight. Instead, I end up, for me, walking to the ferry terminal, waiting for the ferry, taking the ferry to Seattle, and then taking Uber or light rail or some other form of ground transportation out to SeaTac, and it takes a solid hour. If I have to drive around Puget Sound, it's an hour and a half. So thinking about some of the topographical and geographical challenged areas, coastal towns are a great example, which is one reason why Norway is really looking at electrification of aviation. You come to realize that there are some real opportunities to shorten the time spent in traveling. And often it is those people with the lowest paying jobs who live the furthest out. So when you then start to think about a transportation system at, let's say, a regional level, what you want to be thinking about is not how do I get myself up and over congestion, but how do we build a transportation system that reduces the number of single occupancy vehicles on the road. In other words, that the tide raises all ships. So if we can use air mobility as a mode in a multimodal system, and because of that, we are able to increase levels of service to buses, to transit. We improve our light rail. Now we've created a system that improves mobility for everybody, even if everybody isn't flying in the air vehicles for whatever reason. We increase the equity and sustainability of the entire system. I think an area like Seattle, like Puget Sound, is a great example of that because of the islands, the water, the mountains. It just really brings it into focus because of those geographic challenges. But the same can be true for an area that doesn't have those challenges.
Yeah, and I mean highway systems and that are already maxed out can be equivalent. Those types, you know, they're not water obstacles, but they're throughput obstacles. I know one use case on the air taxi side that's talked a lot, and you mentioned it, is, you know, we fly kind of the long distances commercially, and we're all familiar with that. But you get to a SeaTac or you get to an LAX airport, and you want to go to Malibu or you want to go to Disneyland with your kids, and you're ending up, you know, jumping through many different systems to get there. And I think a very near-term use case for these air taxis is to be able to get off your commercial flight for kind of that long haul, do the last mile that we talk about with, you know, ground delivery and transportation, but do so through the air, and take the congestion off of the roadways. And you're already in an airport kind of environment. I wanted to leverage the fact. Sorry, I thought you had something to add. I wanted to leverage the fact that we have Tom here, who's operated rotary wing aircraft and fixed wing aircraft in an urban environment, though. And I think one thing that's very important, and we've seen this also, you know, with autonomous driving, is to recognize, you know, these are environments that are complex, that humans are highly trained to operate within. And so while there's been you know, new technologies that have enabled vehicle designs that may make these modes of transportation more feasible, there's still some practicalities of how these systems are going to integrate with the existing operations. I think the work you've done both with survival flight, but also just you know, doing I think it was a news network that you flew as well, right? Flying those helicopters in an urban environment probably gives you unique perspective. So yeah, curious your thoughts on you know, what are even the challenges with manned flight, and as you kind of see the industry talking about this scale up of these new vehicles, both the small drones as well as the eVTOL, you know, what thoughts come to your mind? What challenges and opportunities?
Yeah, thanks, Eric. I think they kind of piggyback on what Clint alluded to earlier. We have some capability to do this now with manned helicopters and have had that for a long time. And one of the challenges is obviously cost. And so it will be interesting to see if some of these advanced emerging aircraft will be able to address that or not. Certainly by achieving some maybe remotely piloted or unmanned operation, you would reduce the salary load of the pilot. But we've said for a long time that self-driving cars are right around the corner, and I don't see them. And last time I had one of my cars crashed by someone in my family, we went to the impound lot, and there was a lot of Teslas at the impound lot. So I'm just saying, we've got a little ways to go there. And so I take this with a grain of salt. There's a lot of hard work to be done there. Humans are really good at processing data and making quick decisions, and robot technology is amazing, but I think duplicating what a human does is complicated, and we're a little ways from that. Another challenge is obviously just the cost of the vehicle, right? The safety expectations when it comes to transporting humans are high. We all expect that when we get on an aircraft, we arrive at our destination safely and without any fuss. And that safety takes money. It takes aircraft maintenance, it takes aircraft design, certification standards. And with these emerging machines, there will be maintenance costs, and it will be interesting to see if we can keep the cost of the vehicle and the cost of the maintenance lower than a current helicopter or not. So those are some of the challenges, and then we also will have challenges when we start to mix the vehicles together. So when we have these emerging, maybe electrified vertical takeoff aircraft, whether they're piloted or not, mixing them with the current fleet of manned aircraft will take some work.
Yeah, and I think just to quickly touch on that, you've also, working in the hospital environment ecosystem, there's been a lot of attention on the smaller UAS or the drones being part of the medical supply delivery within a hospital ecosystem. And I know when you and I talked, there's a concern. You're talking about mixing vehicle types. Flying the survival flight helicopters off the rooftop of a hospital today, you have limited risk and likelihood of interacting with other aircraft until you're kind of up and away into the established airspace. But now, walk us through what do you think about when there's a concept of now having these smaller, drone aircraft possibly, at some amount of scale in a hospital system, operating in the same shared space that survival flight operates?
No, that's a great question, Eric. So we're talking about the idea of maybe having a small, maybe 100-pound drone, so to speak, maybe a combination of a vertical lift and fixed-wing asset that would move, maybe medical supplies, drugs, different things. And the vision is that they would come to and from the main medical campus fairly regularly to move things. And so we're going to have to learn to interact safely with those aircraft. And there's a lot of challenges. Again, on the manned aircraft side, we have processes for these, right? We have operating procedures whereby the pilot talks to other pilots so they make sure they've got verbal communication between the two. We have some traffic alerting systems through the FAA's ADS-B network, which is essentially a line-of-sight system that sends signals from one aircraft to another or from an aircraft to a ground station that would then get rebroadcast. And so far, the FAA has dictated that unmanned, quote-unquote, drones and manned helicopters will be on different reporting systems. So when my aircraft reports to the FAA network through ADS-B, that could be received by a drone, but the drone's report out is not received by my manned helicopter because they're on different protocols per the FAA's guidance, out of concern that maybe there may eventually be so many drones that it would overwhelm the manned aircraft system. So that's going to be one of the challenges, is how does the unmanned aircraft see the manned aircraft? And how do we make sure that we don't interact with each other while we're both trying to fly into the hospital? And so some potential solutions are flight path management, but it's going to take more than that. The unmanned aircraft will have to have some way to monitor for the manned helicopters and to communicate with us, I think. And that's going to be one of the hurdles we'll have to learn to work through.
Yeah, one thing that's always been very interesting to me in drawing parallels with the technology advances on the ground transportation side is aviation has a long legacy. Clint alluded to it on automation and technologies that make it a connected ecosystem. But it's been kind of incrementally developed over the years, and these systems, while they're in place for the larger aerial transportation modes that we all leverage daily, they weren't designed for all these different modalities, and so there is a challenge of how do you integrate with the existing infrastructure, but then also how do you roll out in a quick enough manner new systems. And so I think, Dimitra, you've done work on unmanned traffic management. I'd love to hear on the research side, what are some of the perspectives there? And also, as we kind of segue a bit more into the technology aspect, we've talked about optionally piloted, remotely piloted, and autonomy. The audience here, I'm sure, is familiar with that on the automotive side, and love to hear, some perspectives on autonomy as well.
Yeah, absolutely. So, from the research perspective, I have heard and I agree with what has been said on the panel on the challenges on. It's an opportunity to use the third dimension and try to, maybe congest the floor level, but at the same time that brings congestion, on the flight level. And then the question would be, how do we handle that? So scalability, like how do we enable safe coordination of all those vehicles, especially when they will not be all working under the same paradigm. There will be a mixed traffic of manned aircraft, manned helicopters, unpiloted, bigger aircraft, smaller drones. And there are discussions, there's definitely a lot of thinking in how this is going to be enabled and integrated in the national airspace safely, and being able to support all the congestion that's going to be created without necessarily the human in the loop in the same way that we currently have it in commercial aviation or even general aviation operations, or even with, the traffic management, unmanned traffic management that needs to be established. So ways to go forward have been proposed as maybe different flight corridors, flying at different levels, but to the best of my knowledge, there has not been any specific paradigm that has been established yet. And when it comes to research, all these aspects of how do we handle all these new types of aircraft that are going to be flying over urban environments or even suburban environments, and how they're going to be handled on the vehicle level. So we're talking about novel challenges when it comes to the vehicle-centric design itself. We're talking about VTOL aircraft. We're going to be combining the vertical takeoff, we saw nice pictures earlier, with quadrotor-like aircraft that can also have variable pitch propellers that can help them transition and flight horizontally as well. This on its own, even at the single vehicle level, creates very nice, interesting problems on how you can have safe flight mode when you have to transition in between now the traditional horizontal or cruise flight that you would have with a fixed wing or a mix now of variable pitch and fixed wing flight modality. Plus the last leg, it's going to be the beginning of the phase that's going to be the vertical takeoff from the vertiport, or the landing close to your yard in order to deliver the package or anything else. So all the way from aerodynamics to flight controls on a single vehicle, these are ongoing research topics, how to make it quiet, how to make it affordable. And then think of it as now you're going to have a swarm of these types of vehicles, included in an air traffic management system that will involve the helicopters, that will involve the hobbyists that will be flying their own drones. All this is going to create a very challenging ecosystem that even from where safety, establishing safety is an ongoing research topic. And centers like CAMS, for example, that I mentioned earlier, try to bring together the government, the industry, and the universities in order to tackle some of the problems. Obviously, not everything is going to be tackled at the level of an NSF-funded project, but in order to make steps moving forward. Other aspects when it comes to research topics that, apart from the guidance, navigation, and control, and autonomy, and coordination, research aspects that we handle within the CAMS, is perception, is sensing. So in order to be able to fly autonomously, you want to be able to have certified and reliable perception so that the vehicle understands where it is, sees and knows where it is with respect to its surroundings. Other aspects are cybersecurity, also related to the automotive industry as well. All these frequencies could be vulnerable. How can we guarantee that communication is going to stay reliable? It's going to stay invulnerable with respect to potential malicious handling of data and communications. All these are aspects that see this ecosystem from a network perspective, and you have your vehicles being nodes in a highly connected environment. And yeah, there's definitely very interesting problems to work on from the university perspective. I'm pretty sure from the industrial perspective as well. Maybe even more there, because you guys handle like the real problems. We stay on the theoretical level for the most part.
Yeah, I just wanted to, thank you for that. I just wanted to add that all of those challenges are within the aviation perspective, but when you step back and think about this from what we call a complete trip perspective, the traveler's perspective, and I, as a traveler, want to be able to look at my phone and say, I'm at A and I want to go to B. What are my options? And just as today, we can look at Google Maps and it'll tell us how long it'll take us if we're going to walk or take a bus or take light rail or some combination. We want that third dimension to be one of those options, but connected with other modes so that it isn't just the aerial mode. It's got to be first mile, last mile if we're talking about cargo or passenger, but giving me my options in terms of how long it's going to take, how much is it going to cost, how many different mode shifts do I have to make. If I need accessibility, are all the modes accessible? Because if one of them isn't, then the whole trip isn't. So as we think about the interconnectedness, we need to do something that aviation really hasn't done before, and that is interconnect and communicate with those other modes. So again, taking Seattle as an example, you can imagine that if you have light rail coming in from the outlying areas into, and let's say we develop a multimodal mobility hub at a light rail station on the outskirts of the main urban area. You've got light rail coming in there, you've got transit coming in there, and you've got urban air taxis coming in there. And people establish certain types of travel patterns. Maybe they take light rail in from just east of the Cascades, and then they switch to an air taxi to get them to downtown Seattle. If on a certain day you have weather such that you can't fly the urban air taxis, what are your other alternatives? How are the other modes going to fill in for those people who had planned to take the air taxi back out to the multimodal hub? Same thing happens the other way. A light rail or a transit system goes down. So it's an interesting, expanding problem when you start to factor in having aviation communicate with the other modes in a multimodal system.
Yeah, thanks. And I think that some threads that are coming up here are heavily around cost. How does this become an affordable additional mode of transportation? And Sarasina, I remember our conversation. I wrote in my notes: scale, 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 scale. And I think a way for these vehicles, which are expensive because of the certification standards, the safety standards, and the new technology, the automation, the autonomy, the connectedness of the ecosystem is essential. And I think in light of that, there's also been a timeline challenge on advancing this innovation. You had kind of this nice concept you'd shared about how do we have a more efficient innovation ecosystem, I'll say, and let you maybe discuss that through the lens of also autonomy and some of these new advanced technologies that we need to bring. And then I'd also like to mention, as part of this cost, maybe as one quick follow-on to this topic too, infrastructure. We oftentimes forget that infrastructure is a large cost, but there's a lot of infrastructure in place as well. And so maybe Clint, we've talked about that a bit too. You could follow up with some discussion on that.
Yeah. First, I just want to Absolutely, Yolanka, as far as making sure aviation is integrated in multimodal. I want to say about, and my husband knows this, maybe about in 2018, I worked with another NASA person and the paper was called The Role of Aviation in Seamless End-to-End Mobility, and it really looked at the passenger-centric model. And it was the first time that I went to present this paper to IEEE AIAA. And it took 6 years, and that NASA person that co-authored it with me, that couldn't actually put his name on it at the time because NASA said they only did aerospace, is now chairing the multimodal steering committee of the AIAA. So that speaks volumes that aviation was always, always outside of all the other modes, and were regulated and certified differently. For example, with the Teslas, you got self-certification, right? So that's why you see them all over the place. And, they can do over-the-air updates. My husband does them all the time. But you can't do that in the current aviation certification framework. But to answer your question, these companies that are building advanced air mobility technologies are coming out of Silicon Valley. And so they are not used to that very regulated certification framework, and not to mention that the infrastructure was designed for manned systems, manned aircraft, but also designed to optimize around airport to airport, which is 55,000 flights per day. I mean, when you go into just a metro like Los Angeles, you'll have 6 million cars, right? And now you want to throw drones, that third dimension, and advanced air mobility. That scale, that number goes, 100x up. And how do we do this? How do we do this safely? And, I want to say, and my dad was an immigrant. He came here because this is the greatest country in the world for innovation and research, and we still are. In advanced air mobility, Joby, Archer, our American companies have filed the most patents in the world on advanced air mobility. And that may have been true with drones, but we lost the drone industry to China. 99% of drones are built in China. They've done the drone swarms. We now are behind in that technology. So this isn't my idea. This is not my chart. NIST did this chart where this was an engineering diagram, on the left-hand side where that, pink is my favorite color, where 70% of the design is done in research and development in the prototypes, but only less than 5% of the errors are found there. And how do we, now that we have these new tools with digital transformation, mixed reality testing, simulation, how can we shift left to reduce the time and the cost to get these vehicles into certification better, right? How do we look at that, putting those verification and validation tools in our research side? And that's why I'm imploring this in the universities. Don't just think about inventing something. Think about inventing the scale of something. I always say, like, my dad invented the RJ-11, which was, with his team. That affected billions of people, but that was when manufacturing of the telephone systems were here. Last week, I went to MIT, and they were inventing great stuff, and two of the researchers had to fly to Shenzhen, China to get it built because they had the ecosystem there. And that is what the AAM Act is imploring us to do, is like, how do we scale innovation here for our national security? When I talk about, wars are not won by innovation, they're won by supply and logistics. And, I'm not talking about a war, but, we cannot compete globally if we don't have the manufacturing, the supply chain, that scale here. It'll go somewhere else. And if you look at, now that we're looking at a complex system of systems, we really need to start testing how those would work in a mixed reality environment, because these vehicles, nobody is not going to trust, throwing out an advanced air mobility, hundreds of throughput an hour over metropolitan areas if we don't test them the way with the tools that are available. And if you look at the integration and test area, that it's like once you get into integration test, you find about 50% of the faults because, as you're throwing out your Teslas into a reality environment, you're really seeing those edge cases, right, in reality. There's no replacement for physical testing, at least, but we do have the new tools and the processes and the people, right, get those regulators into the research side earlier so we can get that verification and validation and get trusted data so that the public, because where the rubber meets the road is at the communities. And if they don't trust that we've tested them correctly, we won't have that at scale here. So I always show this, and it actually took almost a year. I was in policy with mostly policy people across the federal government that finally understood what shift left meant. Shift left came from engineering, came from the microelectronics world, but how can we do that better in research so that we can scale that innovation and do it quicker?
Yeah, thanks. I know lunch is waiting, and we've got a few minutes. Clint and I have talked a lot about infrastructure. I think there's a lot of existing infrastructure that can be leveraged for scale. I also know that you were excited to take a question from the audience and let people engage. I'll leave it up to you if you want to touch on the infrastructure or take an audience question, or if we have one, would maybe be welcome. So.
No, I think let's go to the questions.
Absolutely. So if we've got in the front here.
Skilled workforce requirements to support your vision moving forward? Thank you.
Perfect timing.
Someone wanted to.
I can touch a little bit about it. First of all, my community is really leaned in. So we built the first manufacturing plant that produced a full-scale prototype, and now there's going to be 25. What I saw during the pandemic was pretty fantastic that, if we brought them, where I live is, it's the salad bowl of the United States. It's Monterey County. Salinas Valley produces the most lettuce for the entire nation. What I saw there was when Joby Aviation built their manufacturing plant, they didn't know where to get these workers, right? What worker? It was agriculture workers. They had an advanced manufacturing plant. They had additive manufacturing, all these new skills. A foundation called the James Irvine Foundation, through a 501c3 called Drone Automation Robotics Technology, said, look, give us a certain amount of money. We'll take a group of agriculture workers and train them into these advanced manufacturing jobs. They did this in 6 months with an 87% success rate. And I'm talking about not even high school graduates, low-skilled graduates that they were able to train in these additive manufacturing jobs. And the state of California was then able to see that success, and now gave an additional $6 million to Joby to train additional workers in that area for these advanced manufacturing jobs. So what I see, if we keep this manufacturing here, and now Joby is building their large plant, and train them, whether through Votech or technology, we will be able to have those skilled manufacturing jobs. But I also want to address the pilot certification. And the FAA did an SFAR, which is for the power lift ruling. And what they changed in there through the FAA Reauthorization Act is to look at pilot certification through performance standards. Through the review and examination period, the DoD, through their AFWorks program, took a ab initio group of 40 people that had no pilot experience at all, and they took 40 very highly experienced pilots, and they sent them through simulation training of 2 different type of eVTOLs. One was the Joby aircraft, and one was the Beta aircraft, which is a fixed-wing electric aircraft. just within 4 tries, there were 12 different, it was within the Aviate test. It was hover, land, cruise, and all the flight, simplified flight controls. And what they found was it only took 4 simulation tries, simulation flights, for the ab initio group to be just as proficient in these highly automated systems, right, as very skilled pilots. And so what that shows us is that on an equity side, just getting it, I know there's probably some of you that are general aviation pilots. I went through that training, but I didn't have those hours, right? And it's a very different type of skill. You need to have those hours, those flight hours. It costs $60,000 now to just get a general aviation pilot. That eliminates most everybody in this country. That's except for predominantly one class of people that have the luxury of time and money. And with these new highly automated systems, we can lower that, we can make it more equitable for women to fly, for, lower socioeconomic people to fly, and get them at a proficient level. Joby and Archer is saying if we are able to scale, there would be a shortage of 25,000 to 30,000 pilots in air taxis. So this is, I think, an amazing opportunity for us, all of us, to lean into. The opportunity here, which is a generational opportunity, I think.
Yeah, thanks. I know we have one more question, or at least I think one more, so we'll do a quick one.
Thank you so much for the fantastic discussion. So I mostly do surface automation, autonomous driving. And so one thing I've noticed is in that industry, a single crash can kill the company. We saw it with recently with cruise automation, they lost their CEO, a lot of things have changed. People don't want to fund them anymore. So, and then that's a vehicle, and a vehicle crash we see every day, right? You see thousands of them every year. And people are that sensitive to that autonomous vehicle crash. So a single, Singapore airline yesterday, so it's all over the news, it's gonna stay on the news. So people are more sensitive to that kind of incidents in the air mobility. And so I'm just wondering, so this is maybe a policy question. So from a US DOT perspective, what can be done to provide more confidence to these companies so that they can test these in a more aggressive way to make sure they are ready to be publicly available? Because just testing in an airport, in a very secure area is not going to get them ready to fly over LA, right? So I'm just wondering if there's any policies in place or any plans in place to make that happen.
I know, Clint, you had talked about, you were following a lot of these incidents and capturing the news cycles on it. Curious if you have some just quick thoughts on that. And it's a good question. We certainly can follow up more as we get into lunch here. So.
Yeah, so fortunately, again, we have a long history with aviation, that has learned from past high-profile incidences. And so automation has been a part of aviation, since the 60s and 70s when there were some really high-profile mid-air collisions, which actually, created the FAA. To avoid similar accidents like that. And so, autopilot was installed in the 70s and has been a part of aviation, since then. We've been incrementally improving the whole automated landscape, within aviation since that time. And so this is just the next iteration of what that looks like. And so I'd say that we're already a step ahead of the automotive industry on that side of the house because of the protocols and safety that we talked about earlier of how pilots operate. Now it's just trying to figure out how does this scale? And how do we get more aircraft into the airspace and all this and keep it safe? And so, with that, I'd say we anchor back onto the existing protocols that we have with aircraft certification, operational certification. Each aircraft operates a certain way according to what kind of mission it's flying. The airspace is certified and structured in a certain way, so you operate it within that. Infrastructure has certification protocols on airline at the side of the house. We can draw inspiration from that. And so there's a lot that we can learn from with existing aviation on how we should iterate, into this future of emerging aviation to prevent that. And I think we're in a much better position to do that safely and quickly, than some of the other modes, might be.
Yeah, and we just passed the FAA reauthorization bill that focuses on that. And that's where I'm talking about the innovation around testing, that we have those tools available today to start doing that more rigorously in that research and concept phase, so that once it gets into the certification, we'll have more trust in, not having an accident.
Yeah, thanks. Well, want to thank the panelists for participating. It's a great conversation. Thanks everyone for hanging a little bit extra through the dialogue. And we'll probably, many of us will be around through lunch. So if there's additional dialogue, we welcome you to come and ask questions or engage. Thanks.